The reason why we have to complete the square is not because I'm trying to make you ring through, the seventh circle of hell. It's more the fact is that if I was trying to find two numbers that multiply to get 7, add together to get 4, it's not going to be a thing. There are no two numbers in the whole wide world that will be able to do exactly that. No whole numbers anyway. So what we're going to do is we need to go and force this to become a square. So what we're going to do is I'm going to rewrite this as x squared plus 4x. And you might remember with completing the square, what we do is we half this middle term. So this becomes plus 4 over 2 squared. And then we'll also minus 4 over 2 squared. The reason why we do this is that if you remember the little diagram, that's completing the square, so making that tiny little square there. The reason why we're subtracting it is because we cannot add something without subtracting it unless we've completely changed the equation. We can't do that. We need to add and then subtract so that we haven't just invented a brand new set of numbers. Mr. Schwab.
Well, maybe just did 2 squared.
That's also fine, because that's what's 4 divided by 2, yep. You've just gone one step ahead, so well done for flinging to the top. So what I'm going to do here is I'm going to simplify this bracket here. So this becomes 4 divided by 2 squared, will just be 4, minus 4 divided by 2 squared, that'll be 4, because 4 divided by 2 is 2. 2 squared is 4. And what I can do is I can then get this first part of this answer into a set of brackets. You'll see here what two numbers multiply together to get 4, add together to get 4. 2 and 2. Yeah. So negative 4 plus 7 is going to be what? Positive 3. Okay. So we can see here that actually from this point on, this is as far as you can actually go, because we can't factorize this into brackets, because this is not a minus 3. Had it said minus 3, we'd be able to get in 2 sets of brackets, but that's as far as you would have needed to go with this one here.
During the lesson, some students asked if brackets x plus 2 squared plus 3 would actually factorize to 2 brackets where you would have x plus 2 in both brackets, like what I've done here, and then a square root of 3 in both brackets, but then instead of a plus and a minus, you would have plus and plus. Well, no, because to test to see if you would, you just expand it, and if you expanded it, you get this monstrosity, like an x squared plus brackets 4 plus root 3, x plus 7 plus 4 root 3. At least I think so. I may have skipped a root 3 somewhere. But either way, the point is that it would not be the same as if you expanded x plus 2 squared plus 3. So in order to factorize into brackets, the completing the square must be equal to something like x plus or minus b, where those are some numbers, doesn't matter if it's a plus or a minus, all squared, minus k, where k is any number you like. Which can be put into brackets like x plus or minus b, minus root k, and then the other one would square root of k, I should say, and then the other bracket would be x plus or minus b plus square root of k. So, for example, if you had in brackets x plus 2 squared minus 3, then that would become, in the factorized form, x plus 2 minus root 3, x plus 2 plus root 3.